Hi guys, tonight we're going to take notes on Earth and space. So what that focuses on is how Earth moves as it's going around the sun. There are two words that are commonly misused by sixth graders that I see, and those two words are rotation and revolution. Rotation means spinning. So the Earth spins on its axis once every 24 hours. Now, Earth is a sphere. So the sun, when it's shining its nice bright rays on the Earth, it can only light one side of the Earth at one time. The back side of the Earth is in shadow. So the area that is lit is having daytime. The area that is dark is having nighttime. So it takes us 24 hours to go through and spin one time and rotate on our axis. The other word is revolution. So revolution means that you're going around another object. So Earth revolves around the sun. In fact, all the planets revolve around the sun, and even the moon revolves around the Earth. So it takes us approximately 365 1/4 days to revolve one time around the sun, and that's what we know as our calendar year. But you might be looking at that 1/4 and thinking, I don't remember seeing a 1/4 day on the calendar, and that's because we ignore it for 3 years, because it makes no sense to have a fourth of a day on a calendar. We can't do that. So we ignore it for 3 years, and then on the 4th year, we add them all together, all the 1/4 that we ignored, 1/4 plus 1/4 plus 1/4 for the 3 years we ignored, and then on the 4th year we add in the 4th one, and that gives us one whole day. So every 4 years, we end up with a leap year. And that leap year day that we add in is February 29th. Now, seasons. If I ask you on a test, what causes the seasons, you need to tell me that it's Earth's tilt on its axis and wherever the sun's direct rays are shining gives us summer, and wherever the indirect rays are shining gives us winter. Now, Earth is tilted on its axis, like I just said. So let me come over here and get my pen. So even though you can't see it in the picture, this right here is the North Pole, and then down here we have the South Pole. So because we're tilted on our axis, as we go around the sun, it causes the sun's rays to shine on different parts of the Earth. So right here in this picture, where it is in this spot, the southern hemisphere is tilted towards the sun, so it's getting the sun's direct rays. So it would be summertime in the southern hemisphere, and then up where we are in the northern hemisphere, we're getting the indirect rays. So that would be winter time for us up here in the northern hemisphere. So wherever the direct rays are shining is summer, wherever the indirect rays are shining, it's winter. And that's all because Earth is tilted as it's going around the sun. Okay, so this is an animation that'll show you what it looks like as the Earth is moving around the sun. Notice as it moves, the little red dots at the top and bottom, those are showing you the North and South Pole. The actual tilt doesn't ever change. It's always at the same angle wherever it is in its orbit. So if I can stop it, oh, that's not what I wanted to do, sorry. If we can stop it right here, you would see that the direct rays are shining north of the equator, and when it gets to this spot over here, you'll see that the direct rays are shining south of the equator. So when it's here, then it is summer in the southern hemisphere and winter in the northern hemisphere. And as we're here, it's summer in the northern hemisphere and winter in the southern hemisphere. So it also means that there are two places that mark fall and spring. So let me get back to my pen. This spot here and this spot here mark where the sun's direct rays are right on the equator. When they're right on the equator, then that's either spring or fall. So for us, if this spot right here is our winter, then as we're coming around and the sun's rays work their way back up towards the equator, that means this is going to be our spring. And then over here is our summer. So that means the sun's rays, direct rays, are as far north as they're going to go, and they start working their way back south down here. And then when they reach this spot, they're directly on the equator, so this is our fall temperatures here. And then they keep going south, 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 south. Direct rays are on the southern hemisphere here, so that's our winter. So again, you can look at it as it goes around. Notice the tilt doesn't change, and the sun's direct rays are going to shine on different parts. So right there, they're as far north as they're going to go for direct rays. That's fall. They're right on the equator this time for the direct rays. Now the direct rays are as far south as they're going to go. And now the direct rays are back on the equator, and they're working their way north. And now they're way as far north as they're going to go. So it does that over and over as it orbits around the sun. All right, so the solstices, you've actually already seen them. Where I told you that it was summer and winter for us, those were the solstices. Now, by definition, solstices are when the direct rays are as far north or south as they're going to go. Those 2 days happen to be June 21st and December 21st, and it could be a day or so off. Sometimes it's the 22nd. But they mark our first day of summer and our first day of winter. Spring and fall equinoxes, this is when the sun's direct rays are right on the equator. And again, I showed you with that animation that you just saw where that was. So it marks our first days of spring and fall. And those official dates, again, it can kind of vary by a couple of days, but in general it's March 21st and September 23rd. Okay, make sure you have your notes filled in and bring them to class tomorrow, and we will review seasons when you get to class. Have a good night.